I've seen an article on Hacker News the other day, and the article was talking about TinyBase, which is a relational state management library. We can see that most of the code is only 3 days old. There are only 20 commits in the repository, but it already has 400 stars, which is a really breathtaking amount of stars for such a fresh library. More often than not, when I see some project using one of these state management libraries, it's evident that they don't really need it. Welcome to Get Good. If you're a web developer, then you're probably equally frustrated by some of the state management libraries out there like Redux, Mobex, Vuex, and whatever else they're called nowadays. A few years ago, the web development community was really excited about the whole new paradigm of state management libraries that came out that were based on the Flux pattern or the Flux architecture that Facebook presented back then. I think the first one that was a real commercial success was Redux. Nowadays we have Mobex, Vuex, and so on. And while being very revolutionary and better in many aspects than the existing alternatives or the lack thereof at that time, they also soon became guilty of introducing more and more bloat into our code bases and adding unnecessary complexity. On top of that, there was a kind of peer pressure going on that we all know especially in the web developer communities. Everyone constantly tried to get ahead of everyone else, always bragging about using the latest inventions while also using the latest buzzword framework that was the flavor of that particular month. I mean, if you're a web developer, you know exactly what I'm talking about. And Redux for sure was such a library back then that was a buzzword and that everyone wanted to use in their products. And I've seen bad things. I've seen like Angular 1 projects adopt Redux back when there wasn't even NG Redux or whatever it's called today. They just wanted to be as cool as the React developers, which came a few years after Angular and were the new thing. But what I'm saying is, more often than not, when I see some project using one of these state management libraries, it's evident that they don't really need it. Either the problem they're trying to solve is way too small that it would require such a big, I would say, state management framework, or it can be handled more elegantly and it just doesn't justify the additional development overhead that it introduces. All these things over the last few years have paved also the way for better libraries, I would say, libraries that fixed some of the mistakes that their predecessors did, such as Zustand or Recoil, but still, I mean, they follow the same Flux architecture pattern, and I often really wished for something like a relational state management on the client, on the front end, and this is what we're gonna talk about today. So if we jump to the GitHub page of TinyBase right here, we can see that most of the code is only 3 days old. There are only 20 commits in the repository, but it already has 400 stars, which is a really breathtaking amount of stars for such a fresh library. And I think quite a bunch of people got very excited by this announcement. As I've said, I've seen it on Hacker News the other day. It really looked impressive, especially when you look at the size of this thing. It's between 2 and 5K compressed, which is orders of magnitude smaller than some of the alternatives we know. And I think this is especially good for people who are backend engineers who are used to structured data and who've always been kind of put off by the whole seemingly unnecessary progress made on the front end side, where if you didn't write any front end code for a few months, you would feel like you'd have to learn a completely new programming language when getting back into it. So this is certainly something where you can transfer your backend skills, your database skills easily into the front end. It looks very familiar for someone who's used to relational databases. It's as easy as calling the create store function here, which is something like creating a database. Then you can create a table. In this case, the table is called pets, and you can implicitly create rows already with that function, and each row, let's call it object, can have cells. So in this case, the row with the identifier Fido, which is the name of the dog, has a cell called color, and the value of the color is brown. And these cell values can be strings, booleans, and numbers. Getting data out of the store is as easy as calling the, for example, getRow function, and you specify the table you want to get the row out of, as well as an identifier of the row. You can listen to changes of the store in a reactive manner. There is a guide on how to do that properly, but let's just keep it simple here. So you can listen to the pets table, and whenever there is a change, you provide a function here that gets called every time the data changes. If you're familiar with React, which this library was written for right now, then you of course know how to use React hooks, and you can use various hooks that they provide here for you, such as the useCell hook in this example. And the useCell hook returns the object containing the value of the cell that you wanted to fetch, and it also registers a listener for you automatically that will trigger a re-render if the data changes. You can specify in a descriptive manner what you want to display in the user interface, and these hooks will take care of the whole life cycle for you. For example, we can see here that we use the useCell hook to get the color of the pet named Fido. We save it in a variable here, and we can just display it like this. If the color of the pet would change in the meantime, then this would get updated automatically, and React would trigger a re-render cycle. So if we change here the color from brown to walnut, we will get this update in pretty easily. They also provide a set of components such as row view. It needs a reference to a certain store, the table ID, the row ID you want to view. For example, we see this component in use here. You provide the store you want to get it from, the table ID and the row ID, and then you can actually control how each and every cell should be rendered by providing a custom component as the cell component prop here. So this would fetch the data in a reactive manner for you from the store, and you could still control how each cell should be rendered. You can also apply schemas to tables that defines, for example here, how a row should look like, which cells it should have. And while this library is not type safe, I think many of us, especially in our private projects, can live with a schema like this. It's not really necessary, at least for stuff that's not like very mission critical and on 1,000 production servers. I think we can live with this. We've certainly had worse support than this from many projects before TypeScript was a thing, so I think we can live with this for now. I would love to see, of course, this thing being worked out into a fully TypeScript supported library, especially because you currently don't get auto-completion if you specify a schema yourself. Maybe this is something that they should work towards in the future. And of course, everyone who wants to contribute to this project, feel free to do so. They invite everyone to contribute. The project is MIT licensed, which is not my personal favorite license. You can see in this video here where I talk about some open source drama why I do not like this license, but still you can contribute and make this thing better. I think the stars speak for themselves. I mean, they have 400 stars after 3 days. That's something I've rarely seen. Maybe this is quite common for stuff that gets posted on Hacker News, but at least for me it seems like they've gained more attention than the thousands of JavaScript libraries that get released every day. So, but yeah, there's more. You can define metrics and aggregations, meaning that, let's say you have you're writing an app for your, I don't know, region that tracks the COVID cases in a tabular fashion on some of their government websites or whatever. With this, you can define metrics like the maximum, the average, the median, whatever you can think of, and apply them directly onto the set of cells you're looking at. So you can aggregate, for example, the average number of new cases in a whole region by each row's values and see the average amount of new cases. For example, you can do whatever you want to. I mean, people who know databases, of course, understand this immediately. But I mean, that's something that if you were to use Redux, you would have to fetch the whole set of the array of certain objects, and then you would have to write your own aggregation function. But here it's very simple. You can set a metric definition and it has a set of aggregates that it offers to you here. And I think this can also be extended by your own custom aggregate functions. So this is certainly a useful tool. And one thing that I didn't mention up until now that some of you may have already missed are, of course, relationships, as we're talking about relational structured data here. And of course, TinyBase also offers this feature. You can create relationships between different tables, as you can see here, where we have a pets table and a species table containing dogs and cats, and you can create a dependency, a relationship between these two. In this case, they call it, for example, pet species. Once you have this, you can, for example, get the row in the second table by calling an ID in the first table. So you get the row in the second table that is related to the first one, or you can call the get local row IDs by specifying an ID of the second table. In this case, it would return an array of the two dogs that we have, Fido and Kuyo. You can also create, they call it linked list relationships. Pretty much this is a self-referencing relationship where you can kind of create a sequence of all the elements in the same table. In this case, we call the first row and it returns a sequence of all the other pets that are in this table. You can also, of course, listen to these relationships. So if the data would change in either of the two tables, you would get updates, and you can also provide your own custom functions that can do a lot more than these simple relationships, of course. There are also checkpoints, and checkpoints are pretty much a way of providing a undo redo stack in the store. Essentially, you can create a checkpoint, go back to it, go forward to it, and so on. You can, of course, also persist this data, meaning that, of course, if you just manipulate the store and then reload the page, it would all get lost. But for that reason, there is a session persister, a local persister, a remote persister, and you can persist data either in the local storage, in the session store, in a file if you're using it on a server, or you can provide even a remote server to persist your data on. You can even create custom persisters to create your own way of persisting the data. But the developers have explicitly said that this is not yet used in production in any serious way, so you shouldn't treat it like a real database. You should only persist data on the client side, and on the back end you should use a real database. Before we get to the end, I would like to look at one of the demos that they're providing. You can go to tinybase.org/demos. So let's take a look at this demo here. It's essentially an application that shows you all the countries, and these are supposed to be emojis, but currently I'm on a Windows machine which doesn't like to render these flag emojis for whatever reason. But yeah, you can kind of add countries to your favorites list. This is all saved in a TinyBase relational store. You can skip a bit over the boilerplate code here. You only load the functions and the use hooks and so on that you need. And in this case, there is a country store that gets created using the useCreateStore function, which itself calls a function that calls the createStore function and sets the schema. In this case, every country has an emoji as well as a name. And then we have the useCreatePersister hook here, which calls the createRemotePersister function. And don't get confused by this. The second argument of this function is a load URL, meaning that it loads the default state here. And the third argument is the save URL, which is omitted here, but just so that you can see, this is kind of the JSON data containing the default state here that gets loaded. And then there is a store that saves the stars. So you've seen we were able to favorite certain countries. Once this country auto load is done, the persister gets also called for the stars, and in this case you can provide a default state in this manner here. And then on top of that, it also has a session store here, which creates a session persister. So whenever you revisit this page, it gets saved in your local storage. As I mentioned, there are indexing and metrics functionalities that get mentioned here as well. So you can really easily create, for example, a search function that searches by first letter, or an indexing function that indexes the countries by first letter, which we can see here. So you get all the countries that start with a certain letter. And I mean, if you were to code all of this from scratch, not using all of these nice convenience features, and also imagine that you on the back end you have this nice relational data, and maybe in your head you already have an idea of how the tables look. Then you get into the front end and you have to think about how you want to update certain things, how you want to use Redux, what the dispatcher has to do, which actions you really need. It would take me a lot longer to do it with Redux, even though I've used Redux plenty in my career and I've never used TinyBase in a serious manner. I think I could do it much more quickly with TinyBase in this case. So yeah, I hope that I've given you a small rundown of this library. I really hope that the developers keep improving this, that it becomes more popular. I think it's a great idea because I really like these minimal libraries. And even though one might say that it's not really minimal because you have like 25 different use hooks, I think that they're all pretty much the same thing, but just slightly different. So let me know what you think about TinyBase. Did we finally reach the point where we now have all the things in the browser? You know, it all started with us having like ORMs in the browser, whole full stack in the front end, but now we even have something like a fully fledged SQL database right in the browser. So let me know what you think about that. Subscribe if you want to see more videos like this in the future. I'm a new channel. I have maybe 20 something subscribers right now, so every single one makes me really happy. Let me know if you're planning on using this maybe in one of your fun little side projects in the future. Can it win the fight against the big state management libraries? This kind of state management has a use case that it's good for. I certainly think that for tabular and structured data, this is a very useful tool. I really want to use it in one of my side projects in the future and hope that the developers will maintain it regularly. And once again, thanks for watching this video. Thanks for trying to get good together with me. Hope to see you around next time. Bye bye.